Welcome to Beyond Lab Walls, a podcast from the Salk Institute. Join hosts Isabella Davis and Nicole Milnarek on a journey behind the scenes of the renowned Research Institute in San Diego, California. We're taking you inside the lab to hear the latest discoveries in cutting-edge neuroscience, plant biology, cancer, aging, and more. Explore the fascinating world of science while listening to the stories of the brilliant minds behind it. Here at Salk, we're unlocking the secrets of life itself and sharing them beyond lab walls.
Today, we're coming to you with a special video episode of Beyond Lab Walls, recorded live from Salk's Conrad Prebys Auditorium. Instead of our regular hosts, you have me, Michelle Chamberlain, Vice President of Advancement at the Salk Institute. And this episode is centered around a very special theme: science can't wait. Right now, we're at a pivotal point for scientific research. The pace of discovery is accelerating, the potential for impact is unprecedented, and it's clear that advancing knowledge has never been more critical, nor more challenging. Despite unilateral support for research, there are deep divides about who should pay for it and what areas of exploration should be supported. Changing funding landscapes only add to the urgent need for bold investment in early-stage foundational research like what is pursued at the Salk. Joining me to unpack all of this are two of Salk's visionary leaders, Dr. Jan Karlseder, our Chief Science Officer, and our wonderful Chief Financial Officer, Marie Carter-Dubois. Together, we'll explore what foundational research really means, why it matters, how it's funded, and there we go. Look at that. Did everyone see that? Hit the microphone. I speak with my hands a lot. And close to my heart, what role philanthropy plays in ensuring that science continues to move forward for all of us. So let's go ahead and get started with introductions. Jan, would you like to begin?
Sure. I'm Jan Karlseder. I'm Vice President at the Salk Institute and the Salk's Chief Science Officer. I'm also a professor here. I've had a research lab here since a little bit more than 20 years. And my group, which is currently 8 people, explores how telomeres, which are the ends of the chromosomes, influence aging and cancer initiation.
And I'll just add, for anyone out there wondering, that's an Austrian accent that you're picking up there on Jan.
Unmistakable. Yeah.
What was that?
Unmistakable.
Unmistakable. All right, Marie, please introduce yourself.
Yeah, so I'm going to have you guess my accent at the end. I'm Marie Carter-Dubois. I am the Vice President and the CFO here at Salk. And contrary to Jan, I'm very new. This is the end of my second month. But I come from far away, across the street from the University of California, San Diego, of course. And I was the Associate Vice Chancellor for Finance and Administration on General Campus.
Excellent. And I'm fortunate to call these two colleagues, which really means a lot to me. All right, let's dig in. We're going to start with Jan. Jan, the term basic science, basic research is used a lot. At Salk, we like to refer to it as foundational, really the underpinnings of everything that comes after. What is foundational research and why is it so essential to the progress of science?
So foundational research explores the very basics of biology. So as we try to figure out what makes a cell work, how genes work, how gene transcripts work, how they interact with molecules, and how altogether they form a functioning organism. And of course, we also try to understand what goes wrong in disease stages, so that gives later the opportunity to exploit this. We do this usually before this knowledge gets used and exploited. So we really do this out of curiosity to understand what is going on in a human body and how that body exactly works. And we try to identify really groundbreaking questions for humanity. And that means they don't necessarily always pay dividend right away, but they lay the foundation and groundwork for all therapies in the future. That is what I think foundational research is and why it is so important. Without foundational research, there's just nothing to develop and nothing to translate.
So recognizing foundational research is coming from this curiosity, it's creating knowledge, and it's giving it to the world for therapies and other translational efforts to bloom from them. Can you give me an example of specific foundational research that has come out of Salk?
Yeah, absolutely. There are many of those. I think one of the most classic but also most impactful ones is the research that Tony Hunter is doing. So Tony has been at Salk for, it's been 50 years and we are quite proud of that. But when he started out, he asked a question that became a fundamental question to cancer biology, and that is, why does the infection of cells with some viruses cause cancer? Very important question, really based on curiosity. And what he discovered is that a molecular switch controls many of these processes. It's called phosphorylation, but we don't have to get into those details.
Let's stick with a switch.
Yes, let's stick with switch. So Tony discovered that it plays a role in these viral infections, it plays a role in cancer development, but he could never have anticipated what enormous effect this discovery would have had later on cancer treatment. And we can talk about that a little later. So that's an example from quite a while ago, but there are also much newer ones. I mean, we all know about Alzheimer's disease, and it's a huge problem for our population. It's only going to get worse with population aging, and billions have been spent on trying to understand Alzheimer research, up to, I think, 30 to 35 billion in the last 10 years.
Right?
Yeah, and we have very little to show for it. I mean, there's the therapies that were developed for Alzheimer mostly target the end stage of the disease when we have these tangles and plaques in the brain, and the therapies were developed to dissolve those. That really wasn't impactful because it is way too late in the disease, and that is something where foundational research has to come in and ask the question, what don't we understand? How can we diagnose this disease earlier? How can we treat it before it manifests in those plaques? And that is what we are trying to explore now at the Salk again. And our research leads us to believe that genome stability and chronic inflammation plays a major role there, which now gives us something to explore that has not been explored before.
I appreciate that example because it shows that if we don't understand the foundational underpinnings of Alzheimer's, how can we ever expect there to be a therapy, a prevention, a cure?
Exactly, yeah.
Excellent.
Yeah.
So wrap all that up together and close to my comms heart, make the pitch. What makes foundational science such a vital investment, a worthy investment for our future?
So foundational science provides the basis for all translational science. It's just, as I said before, without the basic knowledge of molecular and cellular processes, there's nothing to build upon and there's nothing to develop further. But I mean, we can also go much more practical because it's a fantastic return of investment to invest in foundational research. It lies the basis, and I want to go back to Tony Hunter here. We talked about this molecular switch discovery before, and he didn't do that with the idea of developing drugs out of it. Yet, over 80 drugs that are used in treatment of various cancers has come out of this discovery. One of them is Gleevec, which many of our listeners have probably heard of. It's a very effective drug. Gleevec was not developed at Salk, but without this initial discovery of this molecular switch, this protein phosphorylation, Gleevec wouldn't exist. Yeah. I think that points out very well how important foundational science is. And will be so in the future, because there are many scientific questions that address human needs that have not been solved. Only foundational research can solve that.
Yeah, I appreciate that. And when I first joined Salk, I learned, so much about our science. And that Tony Hunter example, I think it was around the late 70s that Tony made that discovery, published that to the world. It wasn't until the 90s that there was a pharma company that took it through trials. Right. And then right about the turn of the century, 2001, you end up with Gleevec, and today it hosts a family of cancer drugs. And I take a Pilates class in Solana Beach, and when my instructor found out I worked at Salk, the first question she asked me was, "Do you know Tony Hunter?"
Oh, that's interesting.
And I said, "Absolutely." And she explained her leukemia story to me, and that Gleevec, she has been on some version for over 15 years. And this is my Pilates instructor.
That's amazing.
And so she came to our Joan Jacobs Science and Music earlier this month, and it's just, the impact that his research has had on millions of people cannot be underestimated. And that's just the tip of the iceberg.
Yeah.
So as I now understand, before I started at the Salk, there was no way I could have explained to you the difference between foundational research and translational research. And I didn't understand the unique place that an institution like the Salk Institute has as being that spark, the start of everything that then comes. So recognizing that, is foundational research common? Who else is doing it? And how is Salk unique in that space, if we are? Is there any distinctive qualities for Salk?
It's unfortunately becoming less and less common. But we are not unique. I mean, institutes like the Salk exist. Cold Spring Harbor Laboratories come to mind on Long Island, or Rockefeller University. They do fantastic foundational research. And there are many universities that have departments that still focus mostly on foundational research. But a lot of other departments and research is driven more towards the translational side. And the reason for that is very simple. It's that the funding organizations push into that direction because it gives a quick story to tell. It's immediate gratification, essentially. So there's less and less foundational research done, unfortunately. And an institute like the Salk is unique in many aspects. And that is because of our diverse science directions, the collaborative nature, and also the size of the institute. We only have 50 labs here, so everybody knows each other. But I cannot think of another institute where a cancer biology works next to a plant biologist, works next to a computational biologist, and they all talk about the same important questions and bring in their specific and unique knowledge, but then distill it together. And with that is the way how you can approach a much more complicated question, and you make much more meaningful breakthroughs. In that regards, the Salk is unique.
And Jan, I'm going to go a little off script here because I know we have many people who are architectural fans of the Salk Institute. Can you speak to how the design of the Salk, this incredible brutalist cathedral to science,
absolutely.
How does that impact that collaborative uniqueness that you just talked about?
It's almost, if we talk about this now, it almost sounds like a cliche. but when the institute was established by Jonas Salk, the idea was not to have a place with laboratories that do their thing and don't really talk to each other. So our labs are huge open spaces. You can take a whole floor and empty it and then redesign it because only the outer walls are carrying. So that was a really breakthrough idea back then, but it pays dividends until now because the design encourages interaction. It almost forces interaction. And then, of course, we have this beautiful courtyard in the middle that everybody likes to go and you can just sit out there and meet people and chat.
Yes.
So the design is incredibly functional, also beautiful, but I think the most important of it is that it forces interaction between scientists of different disciplines.
Yep, and I see that every day when I walk through those labs and talk to people. Okay, Marie.
Okay.
We're going to give Jan a break for a moment.
It was inspiring, though.
It is. He is. In terms of the financial model, Salk doesn't receive tuition like universities. We don't have patients and insurance like hospitals. We've always been funded, and our research has always been made possible by a combination of public grants and private philanthropy. Give us an overview of what this financial model looks like and what you're seeing these days.
Yeah, so let me start a little bit to give you a contextual, historical context, because it's important to understand. The NIH is the biggest funder right now, public funder, and the National Institute of Health was funded in back in 1930. But before that, there were a lab called the Hygienic Lab that was created in Staten Island that the government put together to face infectious diseases such as, not COVID at the time, but it was cholera and maybe I don't pronounce cholera correctly, but okay.
Sometimes we say cholera.
And yellow fever and those kind of things. So the sole purpose of this laboratory was really to understand the disease and to try to fight the disease. So a few years later, the National Institute of Health was created in 1930, I believe, and other institute was created under the umbrella of the National Institute. So I think it's important to go back to historical reasons, the context, because this partnership of private and public funding to support foundational research has been, in this country for decades. And it's really vital to support what Jan described so eloquently about what we're doing here at the Salk.
And as we come up almost on the centennial anniversary of public funding of foundational science, today the Salk is about 50-50, right? About 50% of our research is funded through public grants and about 50% through private philanthropy. I certainly have a myriad of stories of how that combination has been pivotal, times when the federal funding has led the way, but many times when the private funding has allowed the research to ripen to a level that the federal grant is interested. So close to my heart again, tell me, Marie, about how private philanthropy, when you're looking at this financial model, how does that see us through rocky moments like this, or even the stable ones?
Yeah, so I think what Jan was referring to in terms of foundational sciences, I picture like how do you learn how to walk, right? And this is this first step that needs to be supported. And often the public funding support science that already has some empirical evidence in order to be eligible to receive public funding. So the private philanthropy is so important because it really helps this first step that can be less attractive to people because not understood, but it's so critical. And this is what we are doing here. We are really at the essence, at the beginning of this discovery. And this is what this partnership of public funding with private funding is key. And we are here, I believe the name of the podcast is Science Can't Wait, because we cannot stop and go. We have to, once we take the first step, we need to continue to walk in order to arrive to discovery, as Jan was mentioning.
Yeah, I think when I talk to our private supporters who, just have the most incredible stories about their attraction to Salk Science, that high risk, high reward, those big questions, they're very attracted to that. And in fact, on December 4th, we'll have a great event for all of our donors that's focused on innovation and impact. It was back in 2006 when Dr. Irwin Jacobs gave us the funding for the very first innovation and collaboration grants. Yeah. And these are not big chunks of money, but it encourages our scientists to come together and ask those questions. And when you look at the leverage that has come from those small dollars, I mean, you're just talking about millions and millions of other funds that have been attracted to them. So very exciting. All right, so for both of you, we all are tracking the headlines every day about what's happening with federal budgetary uncertainties, growing competition for research grants, rumors, facts, it's all in there. At this moment, the federal government is shut down. We've been shut down for about a month, and we're not sure exactly where that's going. That's adding to the uncertainty and dare I even say anxiety. So Jan and Marie, maybe starting with Jan, what impact does all that uncertainty have on foundational research at a place like Salk?
Yeah, you're asking really many questions there. So let's start with the NIH and how it impacts the NIH. Okay. So for us, the NIH is really a numbers game. So the NIH gets a certain budget assigned from Congress, and then they distribute this budget into the different institutes at the NIH, such as the NCI, the National Cancer Institute, or the National Institutes on Aging. And those then take the funds they get assigned and they fund research with that. What we do as scientists is we write grant applications and we send them to those institutes. Like if I work mostly on cancer research, then I write an application where I put my ideas in there and a budget, of course. I send it to the NIH, to the NCI specifically, and there it gets evaluated. And these grants undergo a very stringent evaluation procedure, and then they get ranked in percentiles. And when I was a long time ago a younger scientist, the NCI would pay about 15% of applications, which means if 100 grants get sent in, they get evaluated very stringently by peer review, and then they get ranked from 1 to 100, and the top 15 ones would get funded. This has unfortunately really dropped. So the NCI, when it used to be 15% 20 years ago, now the NCI is at 4%.
Wow.
And that is really problematic. That means that only the 4 best out of 100 applications will get funded, which makes it very difficult because honestly, the difference between a 4th percentile grant and the 7th percentile grant is impossible to determine.
And you've been on these selections, or are
Oh
on
yeah,
these
I
selections.
sit on these committees all the time, and it is difficult because you look at the grant, it's fantastic. It's a great idea. It will advance cancer research or aging research enormously. It should get done, yet you know it will not get done because the percentile of funding is so low. So that impacts careers directly. It is discouraging for junior scientists because they, of course, question rightfully whether that is a career they want to go into. And it impacts science, most importantly, because if something cannot get financed, it will not get done.
Of course.
So I can give you specific examples from the Salk for this. If we go back to Tony Hunter, who is not going to be happy that his name is going to be mentioned so much, but he just sent in an application that got evaluated at the very top level. So it's something that would normally get funded, yet that whole program was abolished. So this is science that will probably not get done until we are lucky enough to find a philanthropic donor that is interested in this direction of research.
And if that's happening to a scientist who's been at the Salk for over 50 years, I can't even imagine what impact it's happening on our scientists that are just getting started.
No, absolutely. And not only at Salk, everywhere. I use Salk as an example because I know it well. But yes, it affects the juniors as well. I mean, one of our very best junior scientists, whose name I'm going to leave out of this, is just got a 5 percentile grant. That's a fantastic evaluation. It's the 5th best out of 100 applications. That's really remarkable.
Absolutely.
It's probably not going to get funded because the NCI is only going to fund the first 4.
Wow. So Marie, how does this environment shape Salk's financial strategy and what we're doing?
Oh, well, I think Jan said it right. Private philanthropy is really key and more critical than ever. There is a real cost of doing research. We need to continue to recruit and to retain the best scientists in the world. We mentioned the beautiful building we are in. I mean, there is a cost to create this, to ensure that the laboratories have the best equipment. So we cannot just stop and go. We need to have a sustainable continuity in research and funding. So this is why private funding is absolutely critical and vital to our mission right now.
I promise all of our viewers and listeners, I did not ask Jan and Marie to speak so much to philanthropy, but you can understand the position that we're in. So let me turn to, or not turn, but deepen this conversation about where we are right now, because I had the opportunity to be in Washington, D.C. last month and spent some time talking with our elected representatives and their staffers about the Salk Institute, about foundational research, about science funding in general. And to the individual, everyone was supportive and believed in the power of scientific research. Everyone that I spoke to, no surprise, has been touched by cancer, by Alzheimer's, by chronic illness. Everyone wants solutions, therapies, cures. However, as I said at the start of the podcast, not everyone agreed on how that mechanism should be funded and not everyone agreed on what should be prioritized. And this is where the Science Can't Wait campaign came from for us. It was, we recognize that there are deep discussions happening, but in the meantime, the science can't wait. It must continue. You don't just start and stop science. So with all of that context, Jan, I mean, this becomes a little bit more personal, but what are your thoughts on the fact that there's this unilateral support, but there are these really big questions about how it's going to be funded and what's going to be prioritized?
Yeah, it's a fair question, I think, but I want to revisit one thing that you started out with, and that is that science is not political.
Yeah.
If you get older and you start suffering from a disease, it doesn't matter if you have a D or an R in front of your name. It's just all it needs is a solution, and that is why we have to continue doing science. The question who should fund it is a fair one, and what I always question is if philanthropy or the government, the federal dollars don't fund foundational research, who else would do it or who could do it? And there are people that suggest that biopharma should jump in. I don't think that's going to work because biopharma has a very different role in the process than foundational research. I mean, what foundational research is curiosity-driven discovery and asking really important questions that address human health and haven't been answered yet. What biopharma does is take the results that we produce and then develop them further. That's a very expensive process in itself already. And if you take something that is promising, develop it into a drug, biopharma is spending $300 billion a year on this. There's no need or no reason for them to fund the foundational research as well. We synergize, but we do very different things. We're also beholden to very different identities. I mean, what foundational research is beholden to is excellent research, truth, and the taxpayer. Biopharma is beholden to shareholders and to success and to profit, which is fair because they spend a lot on this. So it's really two very, very different things that cannot just be easily mixed. I mean, we synergize, we work very well together, but we do not have the same approach and we do not ask the same questions.
Yeah, well said. I recently read an article that also spoke to when you have private funding, let's say through a biopharma company, that those results can very much be proprietary, and there
Right.
isn't much incentive to share those with the world. So, this article was more focused on GLP-1s, and that maybe as early as the 90s, there were some studies that were starting to show, or some research, not studies, that were starting to show all of the positive impacts, but the pharma company moved away from that, and those results were just shelved, and it took us another 30 years to get back there.
It's a really important distinction. I mean, what foundational research does is we ask questions, we answer them, and then we make the answers available to everybody, essentially for free, because they get published and everybody can read them and look them up. That's not what biopharma does, because they want to profit from that, which is really not a criticism. It's just the nature of the different types of entities.
Agreed. All right, so we're looking up at my little clock here, coming up on our 30 minutes. So last question. Science can't wait. What does that statement mean to each of you when you hear it? Marie, why don't we start with you?
So for me, it means hope. I think for me, it means that it's up to each of us, founders, scientists, public, to support this first step that I was describing that will lead to great discovery. You said we all have somebody touched by Alzheimer or cancer, and science starts here. So I really think for me, it's hope, and we all need a hope these days.
Jan?
Yeah, thanks. I like that. To me, it means that discovery-driven science cannot not just be put on hold, because the questions and the challenges don't go away. If we don't address them now through the research that we do, we will not have the answers tomorrow that we need for the next generation of therapies.
Yeah, I like that. Someone approached me about this recently and said, So if you stop funding foundational research, you're basically saying, we know everything we need to know about cancer. We know everything we need to know about Alzheimer's.
Exactly.
And you can ask anyone on this planet, and no one would say you're right to that.
Yeah.
Well, I want to thank both of you for joining. You are just two delightful colleagues, and the Salk Institute and the future of science in the world is just so grateful to have your contributions. For our audience, we have just a couple of takeaways. If you continue to be, interested and deserving and desiring, I should say, of progress in cancer, Alzheimer's, chronic illness, know that new therapies and even cures and innovations, they start with foundational science. And we need to make sure that they are around for not only us, but for our children and for our grandchildren. And in order to do that, we have to invest in foundational research today. We've always relied on a combination of federal funding and private philanthropy. We hope very much that that combination continues. But in the meantime, it is the private philanthropy that can really continue the science and make sure we don't have a break. And finally, the science can't wait. And if you'd like to learn more about how you can join us in this endeavor, please visit salk.edu/can't-wait. And together, we'll ensure that that discovery continues. Thank you so much for joining us.
Thank you.
Thank you, Michelle.